Hey everybody, welcome back. So I'm in the midst of the studio build. We are very close to completion. So a little bit still going on here, still in flight. Some lighting and sound issues to continue to work through, but we're getting awfully close. I wanted to briefly step into a 3D printing project just to share a technique that I think is super valuable to learn. It's one that I use all the time, but it's rare that I get a chance to actually capture it on camera. So I said, hey, wait a minute, let me pause for a minute. I want to share this with you. This is a technique called friction welding. It has a lot of parallels to actual metal welding if you've done any welding before. A great example here is I have a honeycomb grid. This is for one of my lights here in the studio. Now, it might be hard to tell here, but this is, as a whole unit, this is too large to print on a normal 3D printer. So we broke it apart into two parts and we need to fuse them together. Now, you could just slather some glue on there and slap them together and be done with it, right? However, what's the fun in that? How about if we learn a technique for actually bonding these two parts together with a technique called friction welding? This involves using some of the same filament that you use in your 3D printing and a Dremel or rotary tool, and use friction and heat to actually fuse the parts together, and it creates an incredibly strong bond. The final part itself will be just as strong, if not stronger in some ways, than a fully 3D printed single part. So let's check it out. We'll show you how to do it. There's some technique to it, there's some finesse to it, but it's very simple and it's cheap, and once you learn how to do it, I think you'll use it a lot. So let's get started. You'll start by getting your rotary tool and just go ahead and take a piece of your filament and make sure you have a chuck in there that'll fit the right size film in there. Stuff it all the way down in there as far as it'll go down into your rotary tool there, and then go ahead and lock it in, okay? We're gonna go and lock that down. Now, this is obviously way too long, so go ahead and get some clips, and I recommend cutting this off I'd say about 1 centimeter or so to start. So that's going to give us some material to work with here. And it's going to spin around. Now, it's not perfectly straight, as you can probably see, it's wobbling, but that's okay. It's going to straighten out on its own through the process. So I'm going to go ahead and butt this together the way I want it, and be nice and flush in both directions. And I'm going to turn my rotary tool here on. A typical rotary tool is 1 to 10 as far as its speed settings. For me, about a 4 is about right for how fast I want it to go. Let's see if we can get a nice tight shot of that joint. Go ahead and turn up to about a 4 setting, okay? And then I'm gonna go hold that joint in place. That filament is just wobbling all over the place. I mean, if you can tell that on camera, it's not straight, but it will be. So this will take some getting used to. And what you're gonna do is just gently work into that corner. And what's happening is just the filament itself spinning, it's heating up, and it's also heating up the two parts that we're fusing. And this is messy. I'm just kind of going for it for demonstration purposes. Okay? So what you'll do is just continue to work along that. And I recommend, again, if you have any welding experience, you'll want to go ahead and hit a few spots overall to get everything held in place, and then pass back over it and really finish it fully. So I've got a little bit there, and then I'm going to work down into that front corner here. Just making a couple spots. And it'll take some technique to get used to this, okay? Let's do the other side of this. And we're just going to do a nice spot up towards the top. Let's do a little spot towards the top there. And then down on the bottom corner, same thing. A little bit. Turn this off so you can hear me. I'm sure the audio is terrible here. That thing running in the background. Okay, a little bit to be desired there. That's not as tight as I'd like, but what you're looking for is you're gonna get a nice little spot weld there. So that's melting both the parts themselves, heating those two up, and then the filament that you're using from your rotary tool is melting, of course, but they're making a super strong bond. This right here, it's hard to tell, of course, on camera, but that'll make a super strong bond, and that's just a couple spots. We're gonna do that whole seam. Okay, so let's pull back out just a little bit here so I can kind of show you what our overall part is. And even just with a couple spots on there, this is already pretty strong. This is not gonna break. So I have this seam right down the center here. So I'm gonna do a few spots through here just to give it some strength along that seam. And same on the other side. I'm gonna go ahead and hit that and a few spots along here just to give it some strength. And then the areas I'm gonna make sure we fully fill in will be these larger spots. It's just a thicker edge of the part, so that'll be easier to fill in tight. And same on this side, I'll go ahead and fill that up. Again, a cap's a little wider than I would have liked, but it's not too bad. And we're just gonna keep working this. And it just very quickly, it heats up, and you'll fill that gap in. You're not using a ton of material, but you're getting good penetration across that. Okay, now, here comes another great point. So as we can see, that filament down to the nub, we have to pull that out. So what I do, the reason I had you before stuff that is far down in the chuck as it would go, is so that we can now back this out, grab that, and just pull that out. So typically on this particular unit, I'll get like 2 lengths out of one piece here. So I'll stuff this in just far enough for it to grab, and I'm still gonna get about 1 centimeter, right? And then you just repeat this process till you're done. Okay, that looks pretty good. Now again, on the center part here, I'm just gonna do a couple spots along these areas here. Right there. Okay, that's pretty good there. That covers that layer, and then I'll go ahead and finish up and just do this other side here too as well. Again, this is nice and strong here. This is not gonna break. So this here, just to kind of show what we're doing here. So I have one of my LED light panels, and as it is, this is just, it's too diffuse of a light. So using a honeycomb filter like this, this will let the light be a lot more directed. Okay, so for studio setup, these things are great. You can see that that's kind of served our need here. So I've designed this part here to use just a couple of strips of Velcro to go up and over and secure this honeycomb filter to it. So that's it, guys. Just a really quick demonstration on how to do 3D printing friction welding for your larger 3D printed projects. You can use this for really anything that's 3D printed. I love that it uses the same filament that you're using for your 3D printed part. That's kind of cool. You don't have to mess around with any glues or anything like that, and it gets you a nice strong result. So this is one of my favorite 3D printing hacks. I'd love to see some of the ones that you have. We're going to use these for a lot of different projects. I hope this tip is a nice, new tool in your tool belt of 3D printing techniques. Thanks for watching, and stay tuned. We'll be back real soon. The studio is well underway, as you can see, and few improvements yet to do. But we're well underway, and I'm super excited to share some upcoming projects with you. Thanks for stopping by. Please like and subscribe if you found this helpful. Also, post in the comments. I'd like to see what other types of 3D printing tips and tricks and things that you use in your 3D printing adventures. Thanks again for joining me. See you real soon.